Now, first off, the center of everything are these two bus bars. So you have your positive and your negative bus bar. Basically, all these components tie into these bus bars. So I've loosened this one here just so you can see what's going on. So with the bus bar, you have these studs here that allow you to connect in all the components. So all the positives are going to connect to this here, and all the negatives of each of these devices are going to connect to the negative bus bar. For example, you have your solar charge controller right here. The two battery connections, they go into the positive and negative bus bars. For the 3000 watt inverter, you have two connections, they go into the bus bars, and then the battery up top goes through these main positive and negative wires that connect to the bus bars. So this allows you to really connect everything together, kind of like Legos snapping together. Now, we did include a disconnect hub here that goes to the battery so we can shut the entire system down. We have this solar array wires coming through the wall. They go through a 20 amp disconnect, and then they are routed over here to the solar input. Now, this charge controller supports 12 to 48 volt batteries. We are using a 12 volt battery. It's a 60 amp charge controller, so it puts out quite a bit of power. And this supports up to 150 volts open circuit. So the 3 solar panels on the roof in series work just fine with this unit here. We did end up putting a disconnect here so we could shut off the charge controller whenever Nick is not going to be using it, so it's not pulling power from the battery. So that's what this here is a disconnect. Moving up to the inverter, this is a 3000 watt pure sine wave inverter. We'll be demonstrating how this works a little bit later, but very simple and easy to connect up. We have 2 jumpers that go to the positive and negative bus bars. Right here is actually a really cool item that LiTime offers. It's an inline shunt that connects up to the battery, so you can see what's going in and out. You can see the state of charge and the voltage of the battery. So I talked about the battery cables going up through the floor, and you can kind of see there's this battery box here. So if we go up into this loft, you can see the battery has a box built up here. So this is a LiTime 200 amp hour 12 volt lithium iron phosphate battery. It has the built-in heaters. He's actually built this box big enough for 2 of these because he does plan to purchase another 200 amp hour battery to give him 400 amp hours of capacity. We have the inline shunt that's up here for that display that I was showing you guys earlier, and we have a 300 amp fuse coming off that battery. So Nick, now that all this is kind of mounted up to the wall, how did you take the power of the inverter and route it into your shed outlets and lighting system?
Well, first of all, it was pretty simple. Now, it does have 4 outlets along the side of the inverter, so if I wanted to plug directly into that, we can do that. But I knew that I needed tools throughout my shed. So I wired it just like you would wire a home. We took off the side of the inverter, there's ring terminals. I ran my 8-gauge wire into a sub panel. Bought this at Home Depot, really simple. Square D6 panel. I have 3 circuits, 1 for lights, 2 for outlets, each wall.
Now, LiTime advertises this 3000 watt inverter to be a pure sine wave output at 120 volts. So I have my oscilloscope plugged into the outlet that's being powered by the inverter, so let's see what it's actually doing. So looking at the screen here, you can see it's putting out 120 volts AC, and swapping over to the oscilloscope, you can see it is also a pure sine wave output at 60 hertz. So it is putting out really good power. So Nick has been using this inverter for about a week now to power all the tools here in this shed. And it's rated at 3000 watts continuous or 6000 watts surge. So what we want to do now is I want to use my clamp meter to measure the inrush current for a couple of these appliances just to see how much surge they actually require to turn on. We have a massive floor air conditioner here, and we also have a saw, so I'm really interested to see how many amps they take. So in order to measure the surge current for this air conditioner, I'm just using this extension cord with the insulation removed. So I have the clamp meter here on the hot wire. It's set to inrush mode. We're just going to turn this on and see how much it pulls. Okay, so if you can see on the screen there, 37 amps startup inrush current. So for the next surge test, we want to power up this DeWalt 12-inch compound sliding miter saw. Now this is rated at 15 amps. This is a hefty saw. Over here, I have my clamp meter on the power wire so we can measure the inrush current. So we'll turn on the saw and then we'll go look to see how many amps it pulled. So for that test, we measured a total of 45.11 amps in rush. So that saw pulls a lot of power, and the inverter handled it just fine. So this shed is still a work in progress. He's just barely kind of finishing up some of the trim and kind of the decorative stuff of the shed. But you know, kind of what's your long-term goal? What do you want to accomplish in here? What else do you plan to do putting this together?
So quite honestly, this is my man cave, right?
Sweet.
We just don't have the space. We live in the city. I needed a place to come. The fridge, I've got place mounted up for a TV over here. We're gonna have tool storage along the wall. I still gotta finish the floor. It's been fully insulated for summer and for winter. So again, cooling, I'll heat it in the winter time. And the great thing about it is it's all gonna be right off of my solar system.
So we basically covered all the setup for the solar system inside this shed, but you mentioned to me earlier that you implemented one other thing that's really useful if you have some sort of power outage. Can you explain that a little bit?
Absolutely. So when I designed this whole process, one of the things that I wanted to make sure that I could do was use this power should we lose power to our home. So I've added electrical outlets to the front of our shed here, so I can run power cords inside the refrigerators, the freezers, etc. If I needed more power during a power outage, I've got it here in my solar system.
You know, he has the potential to add extra batteries down the road.
And that's the plan, right? So when we built the battery box, right now we've got one battery. We're gonna add more batteries as we need, and it can store more power in that process.
Yeah, so you can get longer run times if the power's out, or run your air conditioner a longer amount of time.
Absolutely,
Yeah.
Yep.